Hello dear students, welcome to my video lesson, which is devoted to aircraft fuel system. So, the theme of the lesson is aircraft fuel system. First of all, I would like to introduce with the aims of the lesson. Communicative to form communicative skills in speaking, reading, listening and writing. Educational, to give the students information about aircraft fuel system and to broaden the outlook. Developing, to develop students' cognitive mechanisms, memory, critical thinking and perception. Consequently, the learning outcomes, ability to speak about aircraft fuel system, ability to use new grammar material, past simple and active vocabulary. Now, students, what do you know about the title of the lesson? What comes first to your mind? Read questions from the slide. Before you start learning this topic, try to find answers to the above mentioned questions in order to refresh your knowledge. So, while aircraft fuel systems are not regarded as one of the glamorous features of an aircraft functionality, they are essential feature of all aircraft. Their implementation and the functional characteristics play a critical role in the design, certification and operational aspects of both military and commercial planes. In fact, the impact of fuel system design on an aircraft operational capabilities encompasses a range of technologies that are much more significant than the non-specialist would at first realize, particularly when considering the complexities of large transport and high-speed military aircraft applications. An aircraft fuel system may be defined as a system which enables the fuel to be loaded, stored, managed, and delivered to the propulsion system engines of aircraft. Fuel systems differ greatly from aircraft to aircraft due to the relative size and complexity of the aircraft in which they are installed. Is the most basic form fuel system will consist of single gravity feed fuel tank with the associated fuels connecting into the aircraft engine. In a modern multi-engine passenger or cargo aircraft, the fuel system is likely to consist of multiple fuel tanks which may be located in the wing or the fuselage, and in some cases the empennage. Each tank will be equipped with internal fuel pumps and have the associated valves and the plumbing to feed the engine, allow for refueling and defueling. This loads the individual tanks and in some applications allow for fuel tamping or for optimization of aircraft's center of gravity. Now, students, I would like to draw your attention to the new words of the lesson. Allow for fuel damping or for optimization of aircraft's center of gravity. Before watching the video about aircraft fuel system, I would like to give list of words with definition. The basic units in the fuel system are the fuel tanks. These tanks contain fuel which is kerosene in the case of gas turbine aircraft and gasoline in the case of piston-powered aircraft. The fuel tanks are an integral part of the wing structure. Fuel can be gravity fed to the engines or pumped by electrically operated boosters pumps. The second, the fuel flow rate of the engines is determined by the setting of the power levers. The pipes which carry the fuel to the engines are fitted with non-return valves and also have to the cocks to cut fuel flow to the engine in the event of the fire. The third and important element in the fuel system is the fuel filtration, which uses filter to remove any contaminations from the fuel before it enters the engine. The fuel is usually heated as it is being pumped to the engines to improve the combustion efficiency. The first fuel loading can be by a pressurized system or by a gravity system. The pressurized system is connected under wing, while the gravity system is connected over wing. Fuel connecting is shown by gauges, which can be shown in the pounds, kilograms, gallons, or liters. Let's watch a video about aircraft fuel system.
In this lesson, we will look at fuel distribution systems. The aircraft fuel system is designed to store and deliver fuel to the engine fuel system. It must be capable of delivering more fuel than the engine can possibly use in its most critical phase of flight, so that the engine is never starved of fuel. Big jets, such as the Boeing 747, can burn as much as 10,000 kilograms per engine per hour during the takeoff phase. Here is a diagram of a simple, single-engined light aircraft fuel system. The fuel tanks are rigid tanks fitted in the wings. They are filled by an open-line refueling pipe through a filler cap on top of the wing. The fuel is drawn from the tanks by a mechanical or electrical fuel pump. Through a hand-operated tank selector, which allows the pilot to use the fuel from either the right or left tank, or turn off the supply completely. The fuel then passes through a strainer, which filters out any foreign objects and debris before being delivered to the engine carburetor. Piston engines often need to be primed with fuel prior to engine start. This is achieved by use of a hand-operated priming pump, which takes fuel from the filter housing and delivers it to the engine inlet manifold. The fuel system is monitored for contents using simple float-operated level sensors, and fuel pump operation is monitored by a fuel pressure gauge. Drain valves allow any water in the fuel to be removed before flight. Multi-engined gas turbine aircraft have more complex fuel systems to cope with the extra problems brought about by high-altitude operations, the use of multiple fuel tanks, and the need to feed the fuel to more than one engine. The fuel tanks are usually integral tanks in the wings. Many modern aircraft may also have a center tank, a tank in the center section torsion box between the wings. Some aircraft types also have fuel tanks in the fin or stabilizer, as well as being used to increase the fuel capacity. This fuel may also be used to change the position of the aircraft's center of gravity. There are a number of components and subsystems common to all multi-engined aircraft fuel systems. We will now look at these in some detail. The fuel tanks are fitted with a vent system. The purpose of the vent system is to allow the air pressure above the fuel in the tank to equalize with the ambient pressure. The areas above the fuel in each tank are connected together by a vent pipe. The ends of the vent pipe terminate in small vent surge tanks located at each wingtip. The vent surge tanks are vented to the atmosphere. The vent surge tanks are there to collect any liquid fuel which might get into the vent system during unusual maneuvering or because of overfilling of the fuel tanks. Any fuel caught in the vent surge tanks is returned to the main tanks either by gravity or by the operation of a pump. Some systems have float-operated vent valves fitted, which close to prevent liquid fuel entering the vent system. The EASA regulations require that when a fuel tank is full, a minimum of 2% by volume of the tank capacity is free of fuel to allow the vent system to operate correctly. If during refueling the fuel reaches this level, then the high-level float switch or volumetric top-off unit will close the refueling valve. As the aircraft climbs, the air pressure reduces.
And now let's consolidate the lesson to post-watching exercises. The task is to fill in the blanks. For example, according to the video, you need to write missing words. In the first sentences, the right words are hands ending starting. Slow warm up slow. For this exercise, you need 5 minutes. Next exercise, if making the statement as true or false. Do not forget to state your opinion. For example, in the second, the right answer is false because turbine fuel has a high knowledge application questions. Answer them and prove your answers. For example, the first answer. If takeoff weight is higher than the landing weight, in an emergency, this aircraft needs to reduce the weight to a specific landing weight. Last exercise is multiple choices questions. Choose the best fair answer. Home task: to learn by heart new words, to write video summary. So, this is the end of the lesson. Thank you for your attention.